My name is Nick Larson, and today we're just doing a little chatting and a little AI, and we're just going to get right to it, I guess. So, we've been working on a project for a while now about doing search for the 8 puzzle. And I feel like, so far we've made really good progress. We have gotten all of the basics implemented. And we've gotten it so that if we run this puzzle, let's go ahead and just give that a shot here. The solver test. If we run this puzzle using our best solving method, we end up with something that's going to print out in just a moment. All right. All right, so we evaluated 7,000, well, about 8,000 states, and we got it done in about 125,000 states a second. And that's in like debug mode on my machine when it's going real slow. So I think the first thing that I want to do is just sort of ramp this up to a 3x4, and then see, just how slow it is. This is going to take a little bit of time because we're going to have to rewrite the way that this works, the way that the state works, because it makes a bunch of assumptions. Um, and then we'll just give it a shot. So first things first, let's go ahead and instead of there just being one dimension, we're going to have 2 dimensions. We're going to call this in rows and in calls. And then total cells, value bits, all of that's going to stay the same. The goal is going to stay the same, the blank row, the blank call. And then I think what we're going to do is this needs to be times in calls. So you take the row times the number of columns, and that tells you how many spaces you need to move over. Okay. Where else is it broken? We want to take in rows and int in calls. And we want in rows. And now we want to do if in rows times in calls is greater than 16, which is the maximum number of cells that we can have, and still store everything in a 64-bit integer, right? Because that would give us 16 times 4 is 64. Yeah. So the maximum number of tiles is 16, but in rows times in calls were requested. Use a little string interpolation. And we want this to be in rows. This dot in calls equals in calls. And then we want in rows times in calls. And then we want generate goal state. This is going to have to be in rows, in calls. And then we want blank call is in rows -1 and in calls -1. All right. Now we want, okay, int rows, int calls, int in rows, int in calls, in rows, in calls. Let's go ahead and say generate. This needs to be rows, int calls. We'll just stick with the naming convention, I guess. in rows times in calls minus 1. Let's see. Divided by n. Divided by n calls. I want to say this is both in calls. Oh crap. Hey, what's up, man? How you doing? I'm just getting started. So what we're doing right now is I'm going to rewrite the way that the state works so that instead of it being just like 3 by 3 or 4 by 4, you can now have it be like a 3 by 4. And what this is going to do is let us ramp up the size of the problem a little bit slower than I was doing. If you remember from yesterday, going from a 3 by 3 to a 4 by 4 takes you from like 180,000 states to like 10 trillion states. And so I really want like a middle step in there so that we can sort of ramp the problem up instead of going from like really easy to really hard. And so I'm just rewriting the state right now to take into account all of the changes, and then we'll rerun the tests and see if everything still works as expected. And then we'll get started with actually working through it. So right now, yeah, just grinding through this. Okay, so this dot, if the blank row in rows in calls. How's everything going on Friday for you, man? Are you about done? And hello and welcome to the stream, everybody. It'd be really nice to meet you, so drop a line in the chat, say hi, and we can hang out. Today I'm just working on rewriting the way that this end puzzle problem works so that we can ramp it up a little bit slower than going from a really easy problem to a really hard problem. And then by the end of today, hopefully we'll be able to solve like a middle-sized problem. Leaving work in about 20. That's awesome, man. You got plans this weekend? It's snowing here right now. It just started. It's really pretty out. In calls. In calls. I'm just going down and trying to get rid of all the red on the right-hand side here, and then we're going to have to go through and fix all these broken things. In rows equals this dot in rows. In calls equals this dot in calls. Yeah, it's been so cold here, man. It's like we only moved to Roanoke like I don't know 2 years ago or so, and in the time since we've moved here, it has been like really, really, really rainy. And then this year during the winter, it's just been like excessively cold. Like last year, it was totally fine. We moved from Atlanta, which is a much warmer city. And here it's just like, it hasn't gone above freezing for the last like 5 days. It's been, well, I guess that's not entirely true. It has been into freezing for more than 12 hours a day for the last 5 days. And it's just been so bitter cold. It's like even walking the dogs is not really that fun. Nothing specific planned, chores, streaming. That's cool, man. What are you going to stream about? In rows. In calls. Expected. In rows. -2. Is that -2 Celsius? Yeah, I heard about your magic mirror project. What is that exactly? Like, what is a magic mirror? Is this something I can Google? Magic mirror. I should probably Google this off in case something crazy pops up. Oh, Raspberry Pi smart mirror. That's cool. Let's take a look at this. That's not what I wanted. No. I need to set it up so that y'all can actually hear what I'm hearing right now, because it's much more interesting than me listening to it and not seeing y'all. All right, how do I do that? Let's see here. Let's add a... add an input. Bloop, bloop. No, I don't want a scene. I want an input. Oh my lord, there are so many choices. Media source, audio, output capture. Let's try that one. We're going to have this be called what I'm hearing. Main computer audio. And then we want it to be the headset earphone. Yeah, that sounds right, huh? Let's try that. Okay. Main computer audio. A software mixer, so I have control over the inputs. I don't see it showing up. Nope, I still don't see it showing up. I don't know how to do this. Properties? I want audio output, right? Let's see this. Oh, there it is. Turn that down. That's crazy. All right. Got that set up so now y'all can actually hear what I hear. Was it too loud? If I play it again? Oh, that's not what I meant to do. Sound about right? Installing node helper. Okay, good. Amazing third-party modules. Facial recognition. That's awesome. Man, this person types fast. So is this just like software or is it like an actual mirror? Is it like a thing you have to buy? Repository. Open source. #1 voted. Oh, look at that. It is. It's like an actual device. Man, that's crazy. Oh, no, it's software? Okay. Build your own mirror. That's cool. Man, that's awesome. All right, I'm definitely going to watch that. Do you do you upload your previous streams or anything when you do them? Can I like go look at them on YouTube? Cuz that'd be awesome. Take a look at what you've done already. Expected row. Calls. All right. This channel doesn't have any content. I don't think that's you. This is what popped up when I clicked on it. Rambling Geek. Did I get... Is it supposed to be lowercase? No. Okay. Not 100% sure there. Hey, there we go. Look at that. That's cool.
All right, so you just hook it up to like, all we need is the Magic Mirror software. I did consider building my own. I was thinking along the lines of a web page in full screen, and then I came across this awesome open source project. That's awesome. Man, that is crazy. So it's like a mirror, and then behind the mirror, there's an actual like screen. That's cool, man. Videos. Twitch, come and watch me. Hey, there you are. Man, that's awesome. Okay, one-way glass. Yeah, I'm definitely going to check that out. I'm going to set this over here and take a look at this when I get done with this today. All right, almost done here. Rows, calls. Let's see. How likely do you think this is to pass if I just try all the tests on the first try? Yeah, int in rows, int in calls. I'm gonna guess 0% chance of this being successful on the first try. In rows, in calls. Of course, you have to finish everything or it won't build, which is awesome. 3.3 state string. Inline data. In. Really what I want to do is 3, 3, 3, 3, 3, 3. And then I want to do in rows, int in calls, in rows. Yeah, absolutely, man. Definitely happy to support you. Like, honestly, when I decided to start streaming, pretty much, I remember talking to my boss about it like months ago, probably back in like October or November, and I was like, I want to do something where it's like I'm working but I'm streaming. And the more we got into like making this a reality, it was like, yeah, there's no way. Like I deal with PII all the time, like personally identifying information. And it was like if any of that ended up on screen, like I would be in so much trouble and the company would be in so much trouble. So we just ended up with like, yeah, we just can't do it like that. But I still was like, yeah, I want to do this. I want to share and like, you know, we get graded on like our mentoring at our office, and mentoring works like inside the company, and then there's like another category for mentoring outside the company. And like, yeah, I definitely just wanted to like start making videos and visualizations because those are the kinds of things that I use to learn. Like I don't, you know, I don't really read, well, I guess I do read books, but I'm more of a visual learner. If I can see the thing happening, then I can understand it like so much faster than just like reading a giant tome of knowledge, you know, with poorly crafted examples and whatnot. But anyway, but yeah, so when I decided to come back to it, I started watching a bunch of other people, and yeah, you were one of the first people that popped up. I think I was following, you know, C Sharp Fritz, and he tweeted, and I went and joined, and then yeah, that happened. I ended up being your 50th, and I felt great about that. So it's been fun. Yeah, like yeah, looking at, like I said, looking at things is just so much easier for me. I understand by looking at something the structure of the way that it's built so much faster than like anything else. Um, yeah, I am definitely not a somebody explain it to me kind of a person. I have to get in there and play with it to to believe it at all. All right, we gotta fix these tests real fast. 3, 3. Okay, let's see if this end puzzle test works. So basically we didn't change anything, and the goal here, how do I make this start scrolling on its own again? Oh, I see what's happening. It's because I'm clicking inside of it. Look, that's crazy. All of the tests passed. So now I feel now I feel great. Let's try a 3x4. And then let's try a 4x3. And then I guess we might as well just try all of the ones that can possibly work. A 2x2. A 2x3. A 2x4. A 2x5. A 2x6. And a 2x7. I guess we can do a 2x8 as well. I don't really want to type this the other way, but I feel like we ought to. 3, just to be comprehensive here. This is the point about like writing unit tests where I'm all of a sudden like, are we testing something that's like valuable here, or am I just writing tests to write tests? And frankly, I feel like I'm just writing test to write test at this moment because we're not actually going to do these. We're going to do a 3x4 and a 4x3 and that's it. So we're just going to test those instead. And then I'm going to feel a little bit better. Come on, no whammies. Hey, all right, they all passed. Let's see if we can actually create a test and see if the initialization works for a 3x4. So again, let's make this a 3. And then let's make this int in rows, int in calls, string state string. Now let's pull this out. Let's do this whole inline data thing. Inline data. Let's do a 3x3 and the state string. All right. Int row. Ooh, look at that. See, I made all of these assumptions. Look at that, man. This is crazy. In rows, in calls, row less than in rows, in calls. Okay. And then let's try something else. Let's go with a 3x4. And that makes this 1, 2, 3, 4. 1, 2, 3, 4. 1, 9, 10. No, 11, 10. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, that's perfect. That's what we want. And then let's do a 4x3 of the same thing. See if we still get the right answer. I really want this to scroll on its own. How do I get rid of the caret so that it doesn't try to stay? Hey, look, these are all passing. Ah, that turned out to be way easier than I thought it was going to be. Now's a good time to check in some code to make sure that it actually works and we have a way to get back to it if we break it later. So update in puzzle for arbitrary in rows in calls. Okay, great. That's awesome. Let's see what's next. So all of these tests passed. Oh, you know, we should do this one, huh? Since this is the next thing that we care about, let's do a 3x4. All right, this one's going to actually take some work. Okay, let's bring this up. Let's go like this. Let's go with an example. 1, 2, 3, 4, 5, 6, 7, 8. All right, man. Have a good drive. Be safe. 10, 11, 0. All right. Okay, now what we want to do is actually calculate this for different values. Yeah, that's right. So let's make a different one, which is like, you know what? I know we can find some 16. Oh no, these are 12 puzzles. I want 12 puzzles. Okay, let's just make some up. Let's go with 3, 7, 7, 9, 11, 4, 8, 10, 0, 5, 2, 1, 1, 2, 3, 4, 5, 6. 6, 7, 8, 9, 10, 11. Okay, perfect. So now what we want to do is actually calculate the Manhattan distance for this by hand so that we can run a test to make sure that we're correctly calculating it. This is the goal state, so all we need to do is figure out how many each of these need to move. So the 1 needs to move up 2 and over 2, so that's 4. And then the 2, it needs to go up 2, so that's 2. And then the 3 needs to go to the right 2, so that's 2. The 4 needs to go up 1 and right 3, so that's 4. The 5 needs to go up 1, so that's 1. The 6 needs to go up 1 and left 2, so that's 3. The 7 needs to go right 1, down 1, so that's 2. The 8 needs to go to the right 2, so that's 2. The 9 needs to go down 2, left 2, so that's 4. The 10 down 1, left 1, that's 2. 11 needs to go down 2, left 1, that's 3. And then we just add all these together. So everybody who's here, thanks for hanging out. Please again drop a line, say whatever. Let's just chat, hang out. It's just Friday, just chilling. If you have any questions, by all means ask. I do a lot better in a conversational setting than just sitting here talking to myself. All right. Oops, tried to go too fast. All right, 4, 2, 2. That's 8, 12, 13, 14, 15, 16, 17, 18, 19, 20, 24, 26, 29. Okay, so this should be 29. All right. Okay. Right here is 29. And then let's go ahead and do one more, which is going to be very similar, but it's going to be the same state, but we're going to do a 4x3, and that is almost certainly going to change the Manhattan value. Okay. So now we want to do a we want to do a 4x3. Okay. So in this case, the 4 needs to come down, the 5 comes up, 7 comes out, the 9, and then this looks like this. Okay. So now what we have is the 3 needs to go, no. The 1 needs to go up 3 and left 1, that is 4. The 2 needs to go up 1, 2, 3 and right 1, that's 4. The 3 needs to go right 2, that's 2. The 4 needs to go left 1. The 5 needs to go up 1, left 1. The 6 needs to go up 2. The 7 needs to go down 2, left 1. The 8 needs to go left 1, down 1 for 2. The 9 needs to go down 2. the 10 needs to go up 1, and the 11 needs to go down 2, right 1, so 3. All right, so 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 26. Yeah, okay, so we did get a different value. All right, roughly same state. We just reoriented it, and we got a different Manhattan value. Now let's run this test and see if they all pass. Toggle output screen lock. Maximize panel. Clear output. Hey, all right, they all passed. This is great. Okay, so Manhattan distance is still working, so our heuristic is still working. The state can now be arbitrary size. The goal check is still working. Really all we need to do is test to make sure that the puzzle can still be solved. All right. Give me just a moment here. All right. Okay, perfect. So I guess let's go ahead and commit that as well. And I'm just going to add that to the last commit because we haven't pushed it yet. Because you should have updated that test already. All right, now let's go to the solver test. And let's try a solver. Ooh, test solver. That's crazy. Test solver is going to have to change. It's going to have to take in... All right, this was assuming 3 by 3. So now we're going to say int in rows, int in calls, and then we're going to change this to in rows, in calls. Okay, awesome. Now let's change these. 3, 3, oop, comma. Whoa. All right, test that these still work. All right, passed. Great, 31 moves. This is awesome. Let's run this Hamming distance. We should still be getting the same values for the number of states evaluated as well. 125, and this one should be right below 8,000. Oh no, I just ran the same one again. That's not what I wanted to do at all. How about we just clear this? There we go. And then run this one. All right. Perfect. Is there a way to make this clear automatically when we run a test? No, it's probably a terrible idea anyway. The only reason I was saying that is because it makes it so that it scrolls automatically, and that's like the only thing that I want it to do. All right, so now we want to do a 3 by 4 and see how long that takes. Test solver. Let's make these a theory. Yeah, let's make this a theory. Do I want it to be a theory? Kind of. Not really. I want to be able to run individual tests. Yeah, we're not going to make this. Well, yeah, no, I want it to be a theory. That's fine. No? No, we're just going to, for this one, we're just going to. All right, stick with the easiest here. And then we're going to do, let's see if we can find the hardest. Hardest 3 by 4 sliding tile game. I want a 3x4. Eight puzzle, 15 puzzle, 16 puzzle. Very difficult puzzles. Hardest puzzles. Yeah, I'm not 100% sure here. We're just gonna make them up as we go. That's my answer now. Okay. So we already created one. Let's go ahead and use that one. We know that it has at least 29 moves, so that's a pretty good starting point. Okay. We want to change this to this. We want to solve it as a 3x4. And we have no idea what the optimal answer is, but assuming this works, it'll just tell us what the optimal answer is. So we're going to give it a shot. Or it's just not going to finish at all. Oh, 37 moves. Okay, that one doesn't appear to have been that difficult. Yeah, so it only evaluated 30,000 states. That's horrible formatting. Let's fix that formatting. I want to make this... Where's my toString? I don't want the test. I want in puzzle. toString is going to be like way down here somewhere. Is goal toString. And I want it to be 3 wide. I don't know how to do that. C# format integer fixed width. How to format a string with fixed width fields. Pad right. That's not what I want at all. Record count. String.format. -18. This already seems crazy to me because it's taking in 3 values and only being passed 2. So how does that work? Not 100% there. It's probably an incorrect answer. I really dislike the padding. Record count. Record count. String.format. I don't want string.format. I want, sure, with leading zeros. 122. D8. X8. 22. I think this is it. We just want a comma. I think we just want a comma. Comma D3. D2. I don't know. Let's give it a shot. You know what? Let's do this the easy way instead of running this whole thing again. Let's just do string dot, no, let's do int I equals 3, j int j equals 4, and then I want to say $, I, comma, D3, D2. I, comma, D2. Dot dump. It doesn't seem to like that. Is it colon? Maybe. Let's give that a go. And then this is more text. Okay, so it did put the leading zeros on there, which I don't want. How do I get rid of the leading zeros? 0, 0? Pound 0? No. Is it possible to put... Yes, you do get a leading space in there. How on earth do I make it do what I want it to do? Fixed width integer. What if I just put 3? Or 2? What if I just put 2? I don't know what that's gonna do. It just made it 2. It just made it the number 2. I2? No. I have no idea. Why is formatting strings so difficult? Does anybody know how to do this? I'm gonna end up wasting like 10 minutes trying to figure this out. I want a fixed width. Oh, that's how. Comma 2. And then pound 0. Or what was it? Pound 0? Is that what I had? Where is... Pound 0. Which clearly is not what I want. So, comma 2, colon, pound 0. Or maybe it's just that, comma 2. Let's try that. Oh, I don't want I want J, comma 2. Yes. All right. Okay, let's try this one more time. Give me the test. Solver test. Run. This is going to fail because we know that the answer is now 37. So it will mark this test as failed. Yeah, failed. Okay, look at that. Look at how pretty that looks, man. That's so much better. Okay, wow. Whew, that just... That's good. 37. Let's get the test to pass. This is a really bad way to be doing a test. I really wish there was like, somebody had solved it by hand in the best possible way. Oh, you know what we can do? We can just use breadth first search, and that'll guarantee us to find the correct answer. Solver. Yeah, let's just do all of them. Although I don't think breadth first search is actually going to finish here, or if it does, it's going to take it a hot minute. Yeah, let's... Let's see if this one finishes. So we can just have an idea about how long it's going to take here. I am staring at a screen. Should start outputting stuff like every 10 seconds. Or it's just capturing the output and it's going to print it all out at the end, because that would be Way too smart. Okay. Let's see if we can get XUnit to write out XUnit write to console while test is running. Capturing output. Console closed. Expected behavior. The string passed to console.writeLine appears in the console. Yeah, I mean, that makes sense to me. You should probably be using iTestOutputHelper, making console.writeLine forward to that may be slightly harder. The issue I was seeing is that it works on OS X, but not on Windows. Oh, that's awesome. That's so great. That's so great. Hooray for that. I am seeing that too on Windows. None of the console.writelines. Can you guys take a look? Console.writeLine. Is it debug console? Terminal. Negative. It's like I know it's running, but now I'm like starting to think that it is actually broken. I mean, the state. Okay, that's the first thing. First is take a look at how big the state space is, which is 12 factorial divided by 2. All right, 900. Did I do that right? 12 factorial divided by 2. Okay, so like 230 million states. We ought to be bumping up a little bit of the RAM usage here. Perhaps. I don't even see it running. Okay, well, it's definitely pegging core 0, so we just need to find it. That's really interesting. Console. I mean, is it running? Did it stop? How do I even test that? How do I even see? Visual Studio Code. It feels like if this was doing what it was supposed to be doing, the amount of memory would be quite large. And I'm not seeing that. I'm seeing an almost constant amount of memory usage. So now I am starting to think that we have a problem. Okay. First things first. Kill it? See? How do I kill it? Maybe it's not even running. There's like no indication here about what's going on. No idea how to stop a unit test from running at all. And before I do something silly, I don't know, let's try just .NET build. Could not do that because it's currently being used. Okay, that's great. How, using Visual Studio Code, do I stop a unit test that is currently running? VS Code stop unit test from running. Test results. VS Code terminate all running task. Sure. How to manually terminate a task in Visual Studio. Control Shift Alt T. Okay. Control Shift Alt T. Not seeing it. Debug. Selection. Control Shift Alt. Appearance editor layout. Control Shift. New breakpoint? No. Is that something I had to set, or was it there automatically? There's currently no key for it. Oh, okay, there we go. This is exactly what I ended up needing. To add a shortcut for terminate task in Visual Studio. File preferences, keyboard shortcuts. Sure, let's do that. File preferences, keyboard shortcuts. Oh, goodness me. Terminate. I don't see terminate. Terminate task. Control Shift Alt T. Terminate task. Okay. Control Shift Alt T. No task is currently running. I beg to differ. Did it finish? Negative. I'm gonna have to kill the whole thing here. Well, this is one problem. This is one problem. How do I fix this? Save all. Did it fix it? No idea. Well, can I build? Okay. Okay. Let's go take a look at this. Run this test for the 3x3. Okay. All right. So we ran this test. Visual Studio Code is not taking any CPU at the moment. How about we order them by name so it stops jumping around? And we see Visual Studio Code. Okay. I guess what we want to do is walk through it, because this to me is feeling like we have a bug somewhere. Well, you know what's interesting is it did solve it just fine down here, which makes me think that, yeah, it's just trying to go through all of them. But we didn't see the memory growing, which is a little interesting. Maybe it's, I don't know. I really just want the test output. Terminal. We've got these on the easy ones. Console.net test. Oh, there we go. Okay, so we did get a failed test. Let's go fix that failed test, and maybe that's what our problem is. Key not found exception. Open. Also, it didn't print out anything. Does it, like, dump a file somewhere? Bin. Debug. It's a DLL. A DLL. a DLL. I really just want to see the output of my test. Project.razor. What? How did that get in there? Okay. Not 100% sure here. Okay, let's just go fix this failed test, which is adding lower cost replaces state and open set test. Open set test. Adding lower cost replaces state. Sure, let's take a look at this. Adding higher cost is a no-op. Adding a lower cost improves the state. Let's debug this test. Debug. Right here. I don't know how to... Oh, debug test. There you go. It's just a button you click. Load up all your junk. Create the thing. Go push it. If state cost contains key, which it does not, then just add it. If cost states dot contains key cost, which it does not, create a new hash set, add the state to the hash set, add the cost state. Right? Cost states. Okay. This one, if state cost contains key state, which it does, if the cost dot compare to, it's not, so we want to say the state cost of state equals cost. It did update that, so I feel great about that. It did update that. So then I say cost states dot cost dot remove state. Oh. Not cost. I need the old. Got it. There we go. And that was my problem. Var old cost equals okay. How about instead of old we call it existing cost, and then we say existing cost, and then we say existing cost. Okay. Var old cost. Var. In this one, what I just want to do is grab. Okay, states. States.remove, and I want to say if states.count is equals 0, then we want to remove it from cost states altogether. So cost states of existing cost dot remove existing cost. Okay. So pop min account equals 0. I guess we just okay. So then we remove it if we don't need it. And I guess we can wrap that logic up so that we don't break that again, which is private void remove cost state, which is t cost t state, and it's basically this. It's basically this. Yeah, no, we're not gonna do it like that. It's a very small file. We ought to be able to keep it up to date. Okay, these two things are semi the same. All right. Now let's try this one more time. Build. Run all my tests, please. Okay, now they all passed. Now let's try to do, actually that's a good place to check in. Okay. Fix. What was the test that we needed to fix? It was open set test. All right. We were not using the correct logic to remove the value. It would leave a copy in the old cost, which when it found an improvement, this change makes it remove it correctly. All right, great. Okay. Okay, that's perfect. Commit. Great. Okay. Next one is this one. Okay. Fix board.toString, or wait, in puzzle.toString to support better formatting. Better formatting for this. Previously, it was only showing single width characters because it was doing the 8 puzzle only, when we did an 11 puzzle, it looked bad. Great. Commit. All right, and then this last one, let's go test it one more time in open set test. This is done, this is done. Solver test. And all right. Well, I guess first off, let's test this. See if it does what we expect. Okay, great. That one works. 31 moves. Oh, there we go. We got the evals. Okay. Okay, great. So we do a little more evals, but we know that it's correct. The evals will change depending on the implementation that you have, because the order that you expand the nodes isn't the same, and the order actually affects the number of evaluations that you end up having to look at. Okay. Now I want to test this big one more time. All right, we found it in 37 moves. We passed. All right, 37 moves, that's perfect. And 30,000 evaluations. Okay, this is perfect. All right, notice it's a bit slower than we had previously, but that's okay. That is okay. Okay. All right, what's next? We want to test the bigger one. For here. Run this one. I really wish it would just output. That would be so great. Because this like lack of outputting is sort of a problem. All right, it could just be that the Hamming distance is not good enough to reach a solution here, which is totally plausible because of the number of states. I guess in this case, though, we should actually see all right, this time we do actually see the memory going up. So each one of these states, let's see, there's about 100 million, no, 200, what number did we just have? 12 factorial. All right, so 250 million, 240 million, and then our state is our state is 4, 8, 12, 20, 28, 32, 36 bytes long. So 36 bytes times 36 bytes. All right, this should not get above 8 gig, and really it shouldn't get anywhere close to that. But that's our gauge to sort of understand what's going on here as far as how close it is to being done. Oh, we just dropped a bunch of memory. It must have just moved up to the next distance. This is slowly climbing. I say 36 bytes. It's really a little bit more because you still have to create the array as well, which has 8-bit addresses for each of those. So yeah, I really just want a little output from this, a little something to debug or, you know, see what's going on with it. I just can't seem to figure out how to do that, which is a little frustrating. I also don't know how to make it stop other than turning this off, because we didn't run a task, or did we? What is it? Control P? No. Control Shift P. Terminate. Debug. Terminate thread. Did that work? Negative. Okay, Control Shift Alt T. No task is currently running. That's awesome. Ooh. Kind of just want to sit here and let it finish. Kind of don't. Not 100% sure what to do. Not sure how long it's going to take here. Okay, well, I guess because I kind of want to just see this finish and get a number out of it, and then obviously we're never going to run this way again. What do we want to do next? Let's see, what have we accomplished so far? Did we do anything on the to-do list? Implement the test. No, we've 2019 02 01 fixed failing open set test, implemented independent rows and calls. And what else did we do? That's really it so far. We're just trying to get some numbers out of the test. And it is not wanting to finish. My goodness. This is not fast in the least. I really just want some output. I really, really, really just want some console output. How do I get some console output? Okay. XUnit. Let's go back to that. Reopen. That was something I needed to do. Comment. Upvote. Thank you. All right. Docs. All right, this is output. Supports formatting arguments just as you're used to with the console. Capturing output in extensibility classes. I really want it to just write out to the console, please. Output example. New diagnostic message. What? Discovery finished. Discovery starting. Output example name equals class and method. Max threads equals 8. Output example ordered 1 test. Okay. message sync. I test output helper. If you may have previously been writing output to console, debug, or trace. When using xunit.net version 2 shipped with parallelization turned on by default, this output capture mechanism was no longer appropriate. It is impossible to know which of the many tests could have been running in parallel were responsible for writing to those shared resources. Users who are porting code. Okay. Okay. I don't know. How far are we into this? What's the likelihood it's actually going to finish? I would expect the close set to be quite large at this point. And the fact that it's not makes me somewhat skeptical. Okay, well, let's see. We were doing, you know, on previous runs here, we were doing 112,000 states a second. So 12 factorial divided by 2 divided by 112,000 divided by 60. Okay, well that should only take 35 hours. Yeah, so, okay, I'm starting to think, yeah, maybe we ought to just cancel this. Starting to think we ought to just cancel this and just not run it like that. I mean, yeah, that makes sense, right? Okay, let's cancel it. How about can I, oh, there we go. Aha, there it is. That's the one that's running in task. All right, my output should, there we go. The active test run was aborted. Woo! Okay, and we figured out how to stop them without restarting. Double win. Okay. That is a lot of Visual Studio codes running. Was each one of these its own process? Probably. Okay. Okay. That's great. So we were able to solve a generic. All right, let's go look at the big cases. Let's go look at scholar.google.com, and what we want is disjoint pattern databases. That's the one we want. Okay, let's make this really big. And then in here is going to be some examples. $15 puzzle. All right, see, the Manhattan distance says it should take about 400. Was I doing that right? Seconds. Experimental results on the 15 puzzle. 55 seconds. Because it was doing 7 million nodes per second. So we have a number. Let's get to 7 million nodes per second. All right, let's get to more nodes per second. That seems like a pretty solid decision. Yeah, that seems like a pretty solid decision. And then here are some example problems. Let's try one of these. This one's only 81 moves. Let's see if we can actually get this done. I mean, I think the answer is going to be no. Solver test. Cannot really solve larger problems with this method. Okay. Let's go test solver 4x4. That looks really big, actually. That's a 5x5. Let's go back to looking at these. These are all 5x5 puzzles? Yeah, these are 24 puzzles. Okay. Give me some 4x4 puzzles. Okay. Let's go to pattern databases. Privacy error. Give it a shot. Okay. Experiments. Come on, give me the table. Where are they? The appendix compares Manhattan distance using both the French Corf 1985. Okay. Corf 1985. Great. Yeah, there we go. This is the one. Can you highlight this text? All right, perfect. Here they are. Okay. Let's choose some easy ones and some hard ones. This appears to be a fairly easy one. And I'm going to have to type it in by hand. That's okay. Just pull it over here. Just going to type it in by hand. This is, goodness, this is hard. It's number 12, 14, 1, 9, 6, 9, 6, 4. Oh, wait, I don't want commas. 1, 9, 6, 4, 8, 14, 1, 9, 1419648 1257230 1257230 10 11 13 15 10 11 13 15 and the optimal number here is 45. Let's give that a shot. Run test. Okay. All right. Yeah, this is slow. With the Manhattan distance, why is it? This should only have to expand 540,000 nodes. Why is it taking so long? Is a great question. Here's someone's. That's the smallest one. Okay. Not sure here. This is the less awesome part about this kind of work. Just sitting around waiting for things to work or not work. .NET Core host. And now I do want to run these. Okay, there we go. Now we're starting to use some. I really just want my output so it can tell me what's going on. I would like to okay, we're gonna write a little quick hack here to see if we can just write out to the console as we're going. End task. Okay. How are we going to do that? That's a great question. Let's go to our base class, test base, and let's add a private class console writing I test output helper, and then we want this to be I test output helper, and then we want to implement this right line, and then we want to say private I test output helper internal inner, then we want to say public console writing I test output helper inner other main, I guess I'm just making this up as I go, inner equals main. And then what I want to say is console. No, before we do that, let's say inner dot write line message, and then console dot write line message, and then the same idea here, only in this case we want format args, format args. And now here what we want to say is new console writing and let's give that a shot. Let's give that a shot. Feel pretty good about that. Come on, just give me some output. You're just not going to do it, are you? Maybe it's because of how I'm running the test. Oh, I just want output. Oh, I was really hoping that was just going to work. What if instead I had it send debug messages to chat? That would be great. So you could see me running the code and debugging it at the same time. Oh, it's frustrating. It's so frustrating. Do. Man, that's frustrating. None of this is going to work. None of this is easy. I have no idea how fast it's going. Now I need to add in basically a project just called fast that does these things. I mean, I don't have another answer here. This is a lot slower than I thought it was going to be. All right. Not gonna wait for it. Excuse me. In task. That's lame. Okay. "20 minutes to go. And what I want to do is see how many states per second we're doing, period. What happens if I run it? Can I run an individual test? XUnit X XUnit run single test command line. How do I run specific test? Filter. Yeah, there we go. That's what I'm talking about right there. Copy. Terminal. .NET test. Fully qualified name equals fast.search.test And then I want to run. And then I want to run solver test. And then I want to run test a star search Manhattan distance. What's gonna happen? It does not appear to have worked. Or maybe it did. And again, I'm just not getting any freaking console output. You know what we're going to do? We're going to start writing to a file. Ooh, I like that idea. Yeah, I like that idea. Let's do that. Let's do that. Yeah? How about XUnit output to file? Oh wait, it give you some checks. XUnit output to file. It doesn't tell you the test that it came from. I really would like to know the test that it came from. Or is it creating a new instance of these for each test? That's very possible. Okay. So in this case, we can Control C. Okay, that's cool. Oh wait, it was the build that failed? No, build completed. There we go. Okay, let's write out to a file in test base. File writing. File writing test output helper. String file name equals datetime.utc now .toString, and we want to make this month, year, month, day, hour, minute, second. That's good enough. Now we want to say plus dash or dot test output. Okay, and then we're just going to have this be file name. And then we're going to have this be string file name. Represents a class. Does this implement great question. Get me to here, get me to XUnit, get me to XUnit, get me to GitHub? That's not what I want. I want actual GitHub. code. Just take me to the freaking code. GitHub projects. XUnit. There we go. Let's go to source. Let's go to xunit.console. No. T. I test output helper. That looks like what we want. I test output helper. Where is I test output helper? Uninitialize. Initialize. Uninitialize. Yeah, so I'm gonna say uninitialize. We'll take care of that. So what I'm going to say is override. Oh, now I need some help. Uninitialize. Nope. I really just need the implementation here. I test output helper needs to be somewhere near here. Or it doesn't at all. Execution? Utility? Execute extensions. Build core. I test collection order. SDK. I test case order, test framework output. Great. I'm gonna have to pull the whole thing just to search for this one file. T. Where was I? I test output. Abstractions. Okay. XUnit. Not commits. XUnit. XUnit. Code. Source. Is this like in a totally different place? Because I don't see abstractions anywhere. Is that like a different library? Negative. I'm really confused. Console? Syncs. Messages. Common. Yeah. Core. SDK. I test output. I found iMessage bus. That's cool. Using xunit.abstractions. What on earth, man? What on earth? Where is this coming from? Please. Collection. Resources? I don't think it's in here. That or somewhere there is like a giant abstractions class. And that's it. Execution. SDK. Abstractions. Nah, it'd be way too easy, wouldn't it? Utility? No. Messages. That'd be way too. No. No, 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 no. Oh. You're gonna make me clone it. Yeah, anybody who's watching, if you know where I am trying to run some XUnit tests, and I am trying to get some console output or writing to a file or something, and I'm not entirely sure how to do it. I guess I could just, you know what we'll do? We'll just do it like this. Just say private. That's not what I want. We will say string file name. Oops. We're gonna say file name, private read only string file name. This is gonna be awful. It's gonna be so slow. Not that it matters. All that matters is that I actually get the output that I'm looking for, right? Yeah, that's right. This dot file name equals file name. And then instead of these consoles, what we're going to do is we're going to use file using system.io, file.append all text. This is awful. Message. Nope. File name and message plus new line. Let's also do it even crazier. Let's go datetime.utc now. Here we go. Now this is turning into like an actual thing. $. Okay. Squiggles. Datetime.utc now. Yeah, whatever. However it wants to do it is fine with me. And then we're going to say message. And then we're going to say new line. Okay. Same idea here. String.format var message equals string.format. Same idea. Okay. What file name are we going to use? I guess in this case I have no idea where it's actually going to dump this out. None really at all. So we're just going to give it a shot. .NET test, run this one test. And hopefully somewhere a file gets created. It hasn't blown up yet, so about every 10 seconds it should be updating. Okay. Where do we think this file is? There it is. Hey, we got some output. Oh man, that was not hard at all. Only it was hard. Okay, great. We have some output. That's awesome. Okay, and what this is telling us is that we are only doing a few states. Our evals is quite low. Alright, so this number has to get very, very high. And what we should be doing is like an eval diff over the last time period, because this is averaging over the whole thing. And what we see is that it's getting notably slower, but it's actually much slower than this. Like in this last 10 seconds, it only did 40,000. And that's not represented by this. This should be like 4,000 per second right now, but it's 10,000 because it's including all these times up here where it did a lot. And the reason that this is getting slower is because the sorted dictionary has a logarithmic time. And so the more states that we add, the more steps it has to actually execute in order to do its work. And yeah, we can see here now that like we're stuck around like 30,000. All right, let's change the way that this outputs to keep track of only the difference in each time period. And then let's try to make this faster, because this is obviously very slow. But it's 1:57, and that's about it. I'm not really going to do that. We're just going to put that on the to-do list, which is not these. These are going to get done later. And we are going to do this one because this is taking forever. All right, so what we want to do first is change output to show just the stats for the last time period, not averaged over full run. And that we can probably go ahead and get done here in the next like minute and a half or 2 minutes, because it is in the solver test. And what we want to do is basically, as we are running this solution, we are outputting this. We want to track the last timestamp. So states evaluated. Let's go and say reporting timer is doing this. What we want to do is say timer. Okay. Okay. Let's make this a little bit better. Okay. States evaluated. Total evals. States per second. Okay. Okay, last milliseconds. Long. No, double. Last millis equals 0, 0D. Is that how you do it? Double? Yeah, sure. And then what we want to say is var current milliseconds equals timer dot elapsed dot total milliseconds. Wait, no, I want to do total seconds. Double last total seconds. Current total seconds. Total seconds. Current total seconds. States per second equals, oh, and then we want long last evals equals 0 L. Can I please? 0 L. And then we want var current evals equals solver dot states evaluated minus last evals. Well, this is going to keep grinding away. So I want current evals, then I want to just do it like this. Current evals minus last evals. Ulong, sure. Ulong, and then I want to do timer dot elapsed dot total seconds, and then I want current total seconds minus last total seconds, and that's going to give us a better states per second. And then I want to say last total seconds equals current total seconds, and last total evals, no, last evals equals current evals. Okay, now let's give that a shot one more time. And now what this is going to do is show us the actual number of values that is coming out of it. So after about, yeah, there we go. Okay, come on, 10 seconds. All right, so states per second, we did about 29,000 states per second. All right, and then we see it drop off to 17. This is in comparison to this last one where it was 23 on the second one, because this time we're only calculating the difference, or the number of states evaluated in the last 10-second period as an average. And this is a more realistic view of it. So ideally what we would want to have happen is this to not drop so low, because this is quite low. And we're going to take a look at how to do that next time, starting on Wednesday of next week. All right, that's going to be it for today. I'm going to get this all checked in. If you want to play around with it, you can find out where everything is at using this nifty little chat message that tells you where to go find the repo, which is awesome. And yeah, thanks again, everybody, for joining. I had a great time. Thanks for hanging out. Thanks for chatting, and we'll see you next week.